All right, this is going to be a demonstration of using OpenCV and Python to do object detection and tracking in a video stream. So there are a number of ways to detect objects using OpenCV. You can look for a particular color or pattern, but in this case we'll be using HAR cascades, which are essentially collections of these small pixelated features that taken together form a feature vector that defines the object you're looking for. So typically, you would train a HAR cascade for the particular case you're working on, for the particular object that you're trying to detect. But in this case, we'll just be using some HAR cascades that other people have trained that were available online to do, in this case, starting off with face detection and moving on to some other things. There's lots of great documentation online, so check it out if you want to learn more. And if you would rather have a tutorial on getting started with OpenCV and Python, then I'd recommend pythonprogramming.net. This video is just going to be more of a demonstration. So if we take this little piece of code here, using creating classifiers using a HAR cascade for face detection and another for eye detection, we can then use the video stream from the webcam and identify where faces and eyes appear in the image. So, all right, let's try it. Oh, we're detecting lots of things. If I take my glasses off, it should be less confused. Okay, so it does a reasonable job tracking my face and my eyes in the video stream. Cool. So we can extend this to detecting other objects in other situations as well. So a friend of mine recently asked me if I could help him with a project. He's a data scientist in Singapore and has a client in Australia that's looking to count the number of people in any given scene in mall security camera footage. So basically track the number of people over time and from various angles, different perspectives within a mall. So I thought, okay, I can try this with just some stock footage. I downloaded off the internet. This is now showing security camera footage from a mall in Dubai. And so the idea here is going to be count the number of people in each frame of the video such that you could track the total number of people moving through this space over time. All right, so if we just modify our code to search for full bodies instead of faces and eyes and input this mall video footage as our video capture, we can try this. Let's see here. And there you have it. So you can see we're identifying some people, some things that aren't people. We're missing some people, but just with some off-the-shelf components, we're getting to within maybe a factor of 2 of the right number of people in the scene. Pretty cool. So what if we wanted to actually do something with the tracking of the object that we've detected in the image? So I recently talked to a guy who's running a startup that is focused on using cheap cameras like webcams to do image recognition, or basically recognize hand gestures in the video stream from cheap cameras like a webcam to control robots or appliances. So I thought, okay, maybe we could do this with OpenCV and Python to control my computer. So if we modify our code, in this case, to look for hands, so now this is a HAR cascade for hand detection. In fact, it's actually for fist detection. And then use the webcam video stream again and import this other package, OSAX, to control my computer. Then we can track the position of the hand and adjust the volume accordingly based on how I move my hand in the image. So let's try it. And I guess we need to put some music on to make this more interesting. The volume is currently muted. Run the music, run the code here. Okay, so if I move away from the computer, it doesn't recognize my hand. If I make a fist, it sees me. The volume's at 0. Got it set so that in the Y position I can move it up and increase the volume. Go back down, increase the volume, back up. We're getting the more complex backgrounds, like against these paintings, start to lose it. It's a harder time with the complex background. But out here, in the simple background, it's pretty well. Pretty cool. So the way that we would improve upon the performance of any of these programs is to train our own HAR cascade, to train it to recognize actually my fist, not just anybody else's fist, and in this background. Or in the case of the mall security camera footage, to look for people in that particular scene. And so when you train against the background that you're going to be looking for your object of interest in, you can have much better performance. So I haven't done this yet, but the next step is to train my own HAR cascade to recognize all kinds of different hand gestures and just control the computer without even touching it. But I think I'll leave that for next time.